what waits in the deepest place on Earth. Beneath the rolling skin of the Pacific lies a wound in the planet's crust, a scar so vast it swallows mountains whole. The Mariana Trench descends deeper than Everest rises, a chasm of silence and crushing weight where sunlight has never touched. To enter it is to fall into a cathedral of shadows. Pressure mounts with every meter, pressing as though the sea itself is trying to fold the Earth back upon itself. Here, the ocean becomes something alien. Above, the surface sparkles with life. Below, the world is stripped bare. No warmth, no light. Only black water pressing in from all sides, and yet even in this desolation, something moves. Flickers of bioluminescence bloom like tiny stars in a drowned cosmos. Creatures with bodies shaped by impossible forces drift in the dark. They are reminders that life bends, but it does not break. Scientists peer into this abyss not only with cameras and sensors, but with questions older than humanity itself. Could this trench hold echoes of Earth's beginnings? Could it be a living archive of how life first clawed its way from chemistry into biology? Or is it simply proof of life's stubbornness, a message carved in the silence of the deep? That existence will always find a way. The mystery of the Mariana Trench is not only what it hides, it is what it says about us, and about the fragile persistence of life in a universe built from darkness. For as long as there have been stories, the ocean's depths have haunted the human imagination. Ancient sailors, adrift on fragile vessels, looked out into endless horizons and wondered what lurked beneath. To them, the deep was not an empty place. It was alive with monsters. Serpents stretching longer than ships. Kraken with arms strong enough to pull a crew into darkness. Leviathans that swallowed men whole and returned only splinters to the waves. These myths were born not from sight, but from fear of the unseen. The ocean was the last wilderness, and the abyss within it was more terrifying than any land yet to be discovered. Centuries passed, and the myths grew quieter, replaced by curiosity. As science advanced, humanity began to trade legends for instruments. Nets dragged from unknown depths returned with pale, ghostly creatures. Some carried their own lanterns of bioluminescence, glowing like fragments of stars. These glimpses hinted at life surviving in places no sunlight could reach. Still, the deepest chasms of the sea remained untouched. They were written on maps as blank spaces, margins where imagination could still spill beyond knowledge. It was not until the mid-19th century that the first serious attempt to study the deep ocean began. The voyage of HMS Challenger in 1872 marked the dawn of modern oceanography. Its crew lowered weighted lines into the abyss, measured temperatures, and cataloged species never seen before. Their journey proved that the ocean floor was not a barren desert, but a complex and varied landscape. Trenches, ridges, and plains stretched out in silence, mirroring the mountains and valleys of the continents above. The Challenger revealed a hidden world, but it also revealed how little we knew. The deeper the line sank, the more mysterious the ocean became. By the 20th century, technology made it possible not just to measure the abyss, but to touch it. Engineers designed steel spheres and bathyscaphs strong enough to endure the crushing weight of the deep. At the bottom of the Mariana Trench, the pressure is more than 1,000 times that of the atmosphere at sea level, enough to shatter submarines and collapse the hulls of ships as though they were made of paper. For decades, this limit was thought impassable. The deep was Earth's natural fortress, impenetrable to human presence. Yet in 1960, that fortress was breached. The bathyscaphe Trieste, piloted by Jacques Picard and Don Walsh, descended into the Challenger Deep, the trench's lowest known point. As the vessel sank, light faded into darkness, and the water outside grew heavier with every meter. By the time they reached the bottom, they carried the weight of the entire ocean above them. When the Trieste finally touched down nearly 11 kilometers below the surface, the world changed. Humanity had set foot on the very floor of its own planet. Their view through the tiny porthole was not of monsters or desolation, but of fine sediment stirred by their landing. To their astonishment, they reported glimpsing life, flatfish-like shapes drifting just above the seabed. Though later debates questioned what they saw, the descent proved a greater truth. Even here, in a realm more alien than the moon, life had a place. The abyss was no longer only myth. It was real, and it was within reach. And yet, after this historic descent, silence returned. Decades would pass before another human would follow. By the time astronauts walked upon the lunar surface in 1969, no one had returned to the Challenger Deep. Humanity had left footprints on another world before it had truly explored its own. The contrast is striking. We soared into the heavens with rockets and flags, while the deep ocean, far closer yet far more hostile, remained a mystery. Why? The answer lies in the challenge of survival. Every meter deeper brings pressure that multiplies like an invisible fist. At 11,000 meters, the weight upon a single square inch is more than 8 tons. To engineers, it is like building a vessel that must withstand the force of an entire jetliner pressing down upon every thumbprint-sized patch of its surface. The margin for error is zero. A single crack, a single flaw, and the abyss claims everything. This relentless pressure makes the trench feel less like Earth and more like another planet. Instruments creak, steel groans, electronics falter in the cold. Even today, sending machines into these depths requires precision at the very edge of human capability. The ocean resists intrusion, as though it were guarding its secrets, and so the trench became more than a geographical feature. It became a frontier, the last untouched wilderness of Earth. For centuries, people called space the final frontier, yet the truth is humbling. The most alien place humanity has ever encountered lies not in the stars, but beneath our own seas. To journey into the Mariana Trench is to step into a world that does not feel terrestrial. Its silence, its pressure, its eternal night, all strip away familiarity. What remains is a reminder that Earth is not entirely known. Parts of it are as strange and uncharted as any exoplanet circling a distant star. This obsession with the abyss continues to grow, driven by the same questions that compelled the myths of old. What lives here, in a place where life should not exist? What rules of biology are broken or rewritten under these impossible conditions? And what does this hidden world say about life beyond Earth? If organisms can endure the crushing darkness of the trench, perhaps they can endure the oceans beneath the ice of Europa or Enceladus. The trench is not only an earthly frontier, it is a mirror through which humanity peers into the cosmos. The deeper we look, the stranger Earth appears. The ocean floor is not simply another region of our planet. It is a reminder that Earth itself can be alien. It does not always yield to the rules of comfort or familiarity. The abyss speaks in silence, and its message is clear. The story of life is not written only in light and warmth. It is written in darkness, in pressure, in the most unlikely corners of existence. Humanity has always feared the unknown, yet it has always been drawn to it. The Mariana Trench stands as proof of that paradox. To descend into it is to step back into myth, into the same mystery that once filled sailors with terror. But this time, the terror is tempered with wonder. The deeper we go, the more we discover not a void, but a living world. And with every descent, the boundary between what is earthly and what is alien becomes thinner. The abyss is not just a place on a map. It is a question carved into the ocean floor, and humanity, restless as ever, cannot help but search for its answer. The ocean is vast, but the trench is infinite in its own way. To stand on a ship above the Mariana Trench is to gaze at nothing. The horizon stretches in every direction. The sea rolls endlessly. But beneath that calm surface waits a world no human eye was ever meant to see. A place of silence, pressure, and darkness so complete that to enter it feels like leaving Earth behind. Each descent into the trench begins the same way. A vessel drifts over still waters. A hatch closes. Instruments hum to life. For those inside, the journey is both physical and psychological. They are not falling into water alone. They are leaving behind the familiar light of the surface world and venturing into a realm where nothing feels certain. Every second downward carries them farther from safety, farther from warmth, and deeper into a silence that grows heavier with depth. The modern age of exploration has brought machines worthy of such journeys. Unlike the fragile bathyscaphs of the past, today's submersibles are forged with pressure-resistant materials tested at the limits of engineering. Titanium hulls capable of bearing thousands of atmospheres without surrender. Acrylic viewports thicker than walls. Life support systems designed to recycle oxygen, scrub carbon dioxide, and regulate temperature against the icy grip of the abyss. Each descent is a confrontation with physics itself, and every system is a fragile shield against forces that could crush steel in an instant. Among these marvels is the DSV limiting factor, piloted by explorer Victor Vescovo. This craft has descended into the Challenger Deep multiple times, setting records not only for depth, but for repeatability. Unlike earlier missions that dared to go once and retreat, the limiting factor is built for return, for persistence in the face of an ocean that yields little. Its titanium sphere holds only a single occupant, sealed in isolation, yet it represents a triumph of engineering over the immensity of nature. Then there is the Deep Sea Challenger, designed by filmmaker and explorer James Cameron. In 2012, Cameron descended alone into the Challenger Deep, piloting a submersible shaped like a torpedo. Its design was radical, with a vertical profile that cut through the water like an arrow. His descent lasted hours, a slow fall into a blackness that swallowed everything beyond the glow of the vessel's lights. When Cameron reached the bottom, he described the seafloor as a desolate lunar plain, a desert of fine silt disturbed only by his landing. His journey brought not just samples and data, but images, the first cinematic glimpses of a world long hidden. Unmanned explorers have gone where humans rarely can. Remotely operated vehicles, or ROVs, are sent into the deep tethered by miles of cable. They carry cameras, sensors, robotic arms. They drift through the water, mechanical ghosts piercing the abyss with beams of light. Where a human craft might falter, these machines persist. They record the glowing trails of bioluminescent creatures, strange gelatinous bodies drifting in the void, and landscapes carved by forces we barely understand. Each ROV becomes an extension of human vision, reaching into darkness and pulling fragments of truth back into daylight. But the descent itself remains the heart of the mystery. It begins with a world still familiar. Shafts of sunlight follow the vessel down. Schools of fish scatter in shimmering arcs. The water is blue, alive with motion. Then, meter by meter, the light fades. Blue deepens to indigo, indigo to black. The temperature falls. The pressure builds. The sea becomes heavy, immense, unrelenting. Soon no trace of sunlight remains. The vessel is suspended in a void. Outside its windows lies nothing but darkness, pierced only by the glow of its lamps. And then something stirs. Flashes of light bloom in the water. Not reflections, not the ship's own lamps, but the glow of life itself. Bioluminescence. Creatures invisible in daylight reveal themselves in the dark, painting the water with ghostly colors. Some pulse in steady rhythm. Others spark in sudden bursts like stars appearing and vanishing in the night sky. It is as if the abyss itself carries its own constellation, hidden from the surface and revealed only to those who dare to enter. The deeper the vessel falls, the stranger the world becomes. Shapes drift past the glass, alien in form. translucent bodies delicate as smoke stretching tendrils meters long. Creatures with jaws that hinge wider than their bodies, designed to seize prey in a place where meals are rare. Tiny fish bearing their own lanterns, dangling lures of light to tempt the unwary. To the untrained eye, these beings appear monstrous, fragile, impossible. But to science, they are survivors, proof that life adapts not just to comfort, but to the harshest extremes. Technology makes these encounters possible. Pressure-resistant housings protect cameras and instruments from collapse. High-intensity lights cut through water so black it feels solid. Sonar sweeps outward, mapping walls of unseen rock and valleys of sediment. Every system is essential. Without them, the abyss would remain impenetrable, a blank canvas. With them, the ocean's silence begins to speak. For those inside a submersible, time itself changes. Hours pass in the descent, but the monotony is heavy. The outside world offers no landmarks, no horizon, no sky. The vessel falls, and the only reminder of progress is the reading of depth gauges ticking higher. To descend is to surrender to patience, to accept that discovery comes not in sudden revelation, but in slow immersion. The abyss does not reveal itself quickly. It demands endurance. When at last the bottom appears, it is not a triumphant arrival, but a quiet one. Lights sweep over the seafloor. It is barren at first glance, a plain of fine silt disturbed only by the occasional rock or ridge. But closer inspection reveals subtlety. Strange organisms live within the sediment. Amphipods scurry across the floor, transparent bodies carrying nutrients from above. Bacteria thrive in ways scientists barely understand, forming ecosystems built not on sunlight, but on chemical energy. This desert is alive, though its life is fragile and fleeting. Each descent carries risks. The ocean presses with unimaginable force, and even the best designs are vulnerable. A failure in the hull would mean instant death. Instruments can falter, lights can fail, and communication lines can go silent. Those who enter the trench understand this. Every dive is a gamble, every return a victory. Yet the risk does not deter exploration. It heightens it. The abyss becomes not just a place to study, but a frontier to endure. And always the question lingers. Why does humanity return here again and again? The answer lies not only in science, but in something deeper. Each descent is not into water, but into an unknown world. The trench is Earth's own alien landscape, hidden beneath miles of sea. To explore it is to test the boundaries of human curiosity. To witness it is to confront a truth, that the planet we call home is still stranger than we imagine. The descent into darkness is both terrifying and beautiful. It strips away the illusion of mastery. It reminds us that Earth is vast, and that its most profound mysteries lie not in the stars above, but in the waters beneath our feet. The abyss is not conquered. It is only glimpsed, one fragile dive at a time. And with each descent, humanity discovers not only the deep ocean, but the persistence of its own wonder. In the crushing blackness of the abyss, where water bears the weight of mountains and sunlight has never once arrived, life should not exist. Yet here, in a world defined by silence and pressure, creatures move. They are fragile, strange, and resilient. They are proof that the rules of survival are not fixed, but malleable. They bend, they twist, and they redefine what it means to live. When the first cameras and collection nets were lowered into the Mariana Trench, expectations were low. Scientists anticipated emptiness, perhaps a few microbes clinging to the sediment. What they discovered instead was a world both alien and alive. Tiny amphipods swarmed the baited traps, transparent crustaceans shaped like shrimp, their delicate bodies adapted to withstand forces that would crush a submarine. They scurried across the seafloor in numbers, as though the abyss were not a void but a hidden pasture, sustaining life unseen by the world above. Among the most astonishing residents are snailfish, ghostly creatures with bodies that appear too fragile for survival. They are pale, soft, almost gelatinous. Their bones are delicate, their flesh translucent. Yet these snailfish thrive at depths beyond 8,000 meters, deeper than any other fish ever recorded. Their secret lies in chemistry. Their cells are infused with compounds called osmolytes, which stabilize proteins under immense pressure. Without them, the delicate machinery of life would collapse. With them, the snailfish endures where no vertebrate should. Then there are the giants of the microscopic world, xenophyophores. These single-celled organisms grow to the size of dinner plates, sprawling across the seafloor like fragile sculptures. They are enormous compared to their cousins, yet they are built from a single cell. Within their simple bodies lies complexity, harboring entire micro-ecosystems. They collect sediment, metals, and organic matter, weaving themselves into the very fabric of the trench. To see one is to witness biology stretched to its limits, defying expectations of scale. These organisms belong to a category known as extremophiles, life forms adapted to thrive under extreme conditions. In the case of the trench, they are piezophiles, creatures built for pressure. To survive, their biochemistry has been reshaped. Enzymes that normally falter under stress are stabilized by unique molecular structures. Cell membranes, which would collapse under crushing forces, are reinforced with specialized lipids that remain flexible even when compressed. Every molecule of their being has been rewritten to resist an environment designed to destroy. This resilience speaks to a larger truth. Life does not seek comfort. It does not demand familiarity. It simply finds a way. The trench is not hospitable in any ordinary sense. It is a realm of scarcity, of pressure, of cold so near freezing that water hovers on the edge of becoming ice. Yet within these extremes, biology has found solutions. It has rewritten its rules. Life here is not an accident. It is an inevitability, shaped by forces that seem hostile, but are, in truth, another stage for evolution to play its endless game. Philosophically, the trench poses a challenge to human imagination. For centuries, life was thought to exist only within narrow boundaries: air, warmth, sunlight, comfort. The discovery of these impossible creatures erases those boundaries. It suggests that life is not fragile, but versatile. It bends to fit the shape of its environment, whether that environment is a sunlit forest or a pressure-ridden abyss. The trench becomes not a graveyard, but a mirror. It shows that life is not defined by where it begins, but by how far it can reach. This revelation echoes far beyond Earth. If life thrives here, in conditions of darkness and crushing pressure, then why not elsewhere? In the icy moons of the outer solar system, beneath the frozen crusts of Europa and Enceladus, lie oceans deeper and darker than our own. Scientists suspect hydrothermal vents and chemical gradients there, similar to those that sustain life in Earth's deep sea. If amphipods and snailfish can endure the abyss, could something akin to them swim beneath the ice of Europa? Could xenophyophore-like organisms drift across alien seabeds, invisible to us until our machines arrive? Astrobiology has long wrestled with the question of habitability. What does it mean for a world to be habitable? The trench answers that question with defiance. Habitability is not about comfort. It is about possibility. Where energy exists, where chemistry can flow, life may appear. In the Mariana Trench, energy comes not from the sun, but from sinking organic matter, from chemical interactions, from the faint traces of nutrients falling like snow from the world above. If such meager offerings can sustain an entire ecosystem here, then oceans beyond Earth may hold similar secrets. Even exoplanets enter the conversation. Worlds orbiting distant stars may bear oceans hidden beneath ice, shielded from radiation and vacuum by frozen shells. To us, they seem inhospitable. To extremophiles, they may be paradise. If life has reshaped itself to survive the trench, then the universe may be teeming with worlds where biology adapts in ways we have yet to imagine. Yet perhaps the most profound lesson of these creatures is not scientific, but philosophical. The snailfish, delicate and pale, does not conquer the abyss. It simply lives within it. The amphipod does not resist pressure. It accepts it, reshaping itself into something that thrives in silence. The xenophyophore does not rage against the darkness. It builds within it, quietly enduring, quietly persisting. These organisms embody a truth humanity often forgets, that life is not about domination. It is about persistence. It is about adaptation. It is about finding a place, however unlikely, and filling it with existence. When scientists peer into their samples and watch these creatures swim beneath microscopes, the awe is not just biological, it is existential. Here, in the trench, life writes a story of resilience that stretches beyond Earth. It whispers of possibilities across the cosmos. It suggests that wherever conditions allow, even in the most hostile corners of the universe, life will emerge. Not as we expect it, not as we know it, but as it must, shaped by forces that demand creativity. The trench is a paradox. It is both desolate and abundant, crushing and nurturing, silent and alive. To descend into it is to enter a place that feels alien, yet belongs to Earth. The creatures that dwell here are not outliers. They are evidence. Evidence that life is broader, deeper, and stranger than we allow ourselves to believe. And so, the abyss teaches. It teaches that survival is not the absence of struggle, but the embrace of it. It teaches that adaptation is not weakness, but strength. It teaches that life is not fragile, but infinite in form. In the amphipod, in the snailfish, and the xenophyophore, humanity sees not just biology, but philosophy. A reminder that existence bends but does not break. A reminder that, in the vast and silent dark, the will to live burns quietly, endlessly, without surrender. Beneath the rolling surface of the Pacific lies a landscape few have seen and fewer still can imagine. The Mariana Trench is not merely a hollow carved into the ocean floor. It is an alien world sculpted by forces so immense, so unrelenting, that they defy human scale. To descend here is to witness a planet remaking itself in silence. It is to look upon a landscape that, in its rawness and strangeness, feels less like Earth and more like the terrain of a distant exoplanet orbiting another star. At its core, the trench is a scar, an immense wound opened by the collision of tectonic plates. Here, the vast Pacific plate dives beneath the smaller Mariana plate, sinking back into the mantle in a process known as subduction. The trench marks the place where the crust of Earth is recycled, where rock that once formed the seafloor is swallowed by the planet it belongs to. Every day the Pacific plate inches downward, carrying with it sediments, minerals, and the ghosts of ancient oceans. The trench is the visible edge of this vast and hidden movement, a reminder that Earth is not static but alive, forever shifting beneath our feet. This subduction drives the trench deeper and deeper, chiseling a canyon more profound than any valley on land. The Challenger Deep, its lowest point, plunges nearly 11 kilometers below sea level. To stand at the rim and imagine its depth is futile. Everest could fit inside it and still leave more than 2 kilometers to spare. Yet what lies beneath is not emptiness, but a geological theater. Mountains, ridges, and plains spread across the trench floor, shaped not by wind or rain, but by unimaginable pressure and tectonic violence. Hydrothermal vents punctuate this alien terrain. These fissures in the seafloor spew superheated water rich with minerals, drawn from the interaction of seawater with magma beneath the crust. Temperatures within the vents can reach over 400 degrees Celsius, yet the pressure prevents the water from boiling. Instead, plumes of mineral-laden liquid billow into the darkness, forming chimneys that rise like blackened towers. Around them, entire ecosystems thrive, fueled not by sunlight but by chemosynthesis. Bacteria convert the chemical energy of hydrogen sulfide into life, sustaining creatures that cluster in the shadows. To see these vents is to glimpse a form of creation older than photosynthesis, a reminder of how life may have first emerged on Earth. Elsewhere, mud volcanoes rise from the seafloor, belching streams of fluidized sediment and methane. These structures, built from the slow squeeze of trapped gases and water, resemble landscapes from another world. Their flanks are scarred, their peaks crowned with bubbling outflows. They release not fire, but cold plumes of gas and slurry, feeding unique microbial communities. To witness them is to confront a paradox. Volcanoes without flame, eruptions without heat, life birthed from what appears barren. The geology of the trench is not limited to its surface. Beneath the sediment, chemical alchemy is at work. One of the most fascinating processes is serpentinization, the transformation of mantle rock, rich in olivine, when it reacts with seawater. This reaction produces hydrogen gas, a potential energy source for microbial life. It is a process that may echo the conditions of early Earth, when the first spark of biology emerged from chemistry. In the deep, serpentinization becomes more than a geological curiosity. It becomes a stage for life's persistence. Alongside it lie methane hydrates, crystalline structures that trap methane molecules within cages of water ice. These hydrates shimmer beneath the sediment, fragile yet abundant. They are both a potential energy source and a looming hazard. If destabilized, they could release vast amounts of methane, a greenhouse gas more potent than carbon dioxide. In the trench, they glisten as reminders of Earth's interconnected systems, how the silence of the abyss can influence the breath of the atmosphere above. Sonar maps reveal that the trench is not a smooth descent, but a fractured and scarred landscape. Steep cliffs plunge downward in sudden drops. Abyssal hills roll across the seafloor. Fault lines slice the terrain, evidence of tectonic stress tearing rock apart. Landslides bury ridges beneath avalanches of sediment. Each feature tells a story written in pressure and time, a story of plates colliding and Earth reshaping itself in ways too slow for human eyes, but too vast to ignore. To compare this landscape to anything familiar on Earth is difficult. It does not resemble the deserts of the land, nor the mountains above sea level. Its features echo more closely the images returned from robotic explorers on other worlds. The jagged cliffs of Europa, the icy ridges of Enceladus, the barren plains of Mars, all find parallels in the trench. When viewed through the glow of submersible lights, the seafloor resembles the surface of an exoplanet, untouched by human presence, carved by forces that operate far beyond our scale. This alien quality is heightened by the absence of light. Without the sun to lend color, the trench exists in monochrome. Grays and blacks dominate, broken only by the pale shimmer of minerals or the ghostly glow of bioluminescence. Shadows stretch endlessly. Every ridge and crevice appears sharper, every slope more immense. In this darkness, the imagination stirs. One could believe they are standing on the seabed of a distant ocean world, staring across a horizon not meant for human eyes, and yet the trench is part of Earth. Its strangeness is not extraterrestrial, but terrestrial. It reminds us that our planet contains multitudes, that it harbors environments as alien as any distant world. To explore the trench is to realize that Earth itself is a cosmos in miniature, holding within it extremes that rival anything beyond our atmosphere. For scientists, this realization has profound implications. The geological processes at work in the trench offer clues to the history of the planet. Subduction recycles crust, feeding the mantle and driving volcanic arcs. Hydrothermal systems may hold secrets to the origin of life. Serpentinization and methane hydrates illuminate pathways of energy that sustain biology in the absence of sunlight. The trench becomes a laboratory, not just of geology, but of astrobiology. If such processes sustain ecosystems here, then similar ones may sustain them elsewhere. The trench also humbles. It shows that even after centuries of exploration, Earth is not fully known. Vast landscapes remain hidden, their scale dwarfing our comprehension. We look to the stars for wonder, yet beneath our seas lies a world as mysterious as any galaxy. The alien is not only out there, it is here beneath us, waiting in silence. Philosophically, the trench forces reflection. To see its scarred floor is to confront Earth's power to shape and reshape itself. To witness hydrothermal vents is to glimpse creation in its rawest form. To imagine serpentinization and methane hydrates is to recognize the tenuous balance between geology, chemistry, and biology. In these depths, the boundary between Earth and the cosmos blurs. The trench does not feel like part of a familiar planet. It feels like an echo of something greater, a reminder that we live upon a world as strange and vast as any that circles a distant star. And so the Mariana Trench is not merely a geological feature. It is a frontier, a place where tectonic forces carve landscapes of alien beauty, a place where minerals sparkle like frozen fire, a place where Earth's secrets lie buried beneath kilometers of water, waiting for light to reveal them. Each descent into it is not only a dive into depth, but a passage into otherness. The ocean floor, stripped of light and color, becomes a canvas of alien geology. In its cliffs, its vents, its volcanoes, and its hidden deposits, the trench speaks of a truth both humbling and exhilarating. Earth is not fully known. Its landscapes are not fully ours. Beneath the sea lies a planet within the planet, a reminder that discovery is never finished. To descend into the trench is to walk the surface of another world without leaving this one. The Mariana Trench has long stood as a symbol of remoteness, a place so deep, so hostile, that it seemed beyond the reach of human hands. For centuries, it was imagined as a sanctuary of purity, untouched by the noise of civilization. Yet when science cast its instruments into the abyss, the silence revealed a darker truth. Even here in the most inaccessible place on Earth, the fingerprints of humanity are pressed into the fabric of life. In 2019, scientists descended into the trench with a simple yet profound question. Could life at these depths truly exist apart from human influence? Their answer came not in myth, but in the fragile bodies of amphipods. These tiny crustaceans, resilient survivors of crushing pressure, carried within them something unexpected: microplastics. Fibers, fragments, and particles no larger than a grain of sand, woven into their digestive systems. Plastic, created by human industry, had found its way into organisms 11 kilometers beneath the sea. It was a revelation as unsettling as it was inevitable. The deep, once thought untouchable, had already been reached by the detritus of modern life. The journey of these plastics is both simple and haunting. Discarded bottles, bags, and fibers begin their descent from the surface, broken down by sunlight and waves. Over time, they fragment into particles too small to see. Currents carry them outward, downward, until they sink into the abyssal plains. There they are mistaken for food by creatures desperate in a world of scarcity. The amphipods consume them, not as intruders, but as part of their environment. And in doing so, the deepest ecosystem on Earth becomes a reflection of the one above, polluted, tainted, changed. But plastic is not the only intruder. Traces of industrial pollutants have also been discovered, carried on currents into the abyss. Polychlorinated biphenyls, or PCBs, once used in electronics and machinery, persist in the environment long after their production was banned. These toxic compounds accumulate in the fatty tissues of deep-sea organisms, passed along the food web in silence. In the amphipods of the trench, scientists found concentrations of PCBs rivaling those in some of the most polluted rivers on Earth. The irony is stark. In the most remote depths of the ocean, life carries the same chemical burdens as creatures living beside factories and cities. Radioactive traces, too, have made the descent. Fallout from nuclear tests and accidents has left isotopes that drift through the seas, eventually settling into sediments at the ocean floor. The trench, once thought to be a place of natural isolation, has become a repository of the planet's past mistakes. Every particle, every molecule tells a story of human reach. Civilization's waste does not vanish. It falls, and it falls until it finds its way into the deepest silence. The impact is not merely biological, but philosophical. For generations, humanity believed that distance equaled protection, that the farther a place was from cities and machines, the safer it would be from human influence. The trench disproves this belief. It reveals that remoteness is an illusion. No matter how far, no matter how deep, the traces of human existence follow. The abyss, once imagined as a realm of pure earth, now bears echoes of plastic toxins and radiation. It has become a mirror, reflecting the consequences of civilization back at itself. The emotional weight of this truth is immense. The deepest silence carries echoes of human noise. The amphipod drifting in darkness is not only a creature of resilience, it is a witness, carrying within its body the residue of industry, the fragments of a species that has reshaped the world above and now imprints itself upon the world below. The trench does not resist this intrusion. It absorbs it, silently, inescapably. What does this mean for humanity's stewardship of Earth? If the deepest life is already tainted, what hope remains for the surface? The trench was once a sanctuary beyond imagination, yet now it is proof that no sanctuary exists. Every current carries with it reminders of human presence. Every ecosystem, no matter how remote, bears the marks of a civilization unwilling to see its limits. Some may argue that life in the trench adapts, as it always has. That amphipods will endure, that microbes will metabolize, that resilience is infinite. But adaptation is not absolution. The presence of plastics and pollutants is not neutral. It changes chemistry, alters survival, and reshapes ecosystems in ways not yet understood. To study the trench now is not only to glimpse alien landscapes and impossible life. It is to read the story of humanity's reach written in plastic fibers and chemical traces. For astrobiologists, this realization carries both caution and perspective. If Earth's most extreme environments are already altered by human activity, what does that suggest about the search for life beyond? If we find life on Europa or Enceladus, how will we ensure that our own presence does not alter it before we can understand it? The trench warns that exploration carries consequences, that even observation leaves a mark. The abyss is not only a laboratory of biology and geology, it is a warning. A reminder that discovery and destruction often walk hand in hand. The philosophical question grows sharper. What does it mean to explore when exploration changes what is explored? What does it mean to study resilience when resilience is tested not by nature, but by human neglect? The trench, once thought a symbol of purity, becomes instead a monument to interconnectedness. It shows that humanity does not stand apart from Earth's systems. It is woven into them, inseparable. Its actions ripple outward and downward, reaching even into silence. To peer into this truth is uncomfortable, but necessary. The Mariana Trench forces humanity to confront its reflection, not in the mirror of stars, but in the black water beneath its feet. The amphipod with plastic in its gut is not just a creature of the deep. It is an emblem of consequence. The sediments carrying radioactive isotopes are not just geological records. They are chapters in the story of a species that reached too far without considering the cost. And yet, within this discomfort lies a possibility. The realization that even the trench is touched by humanity means that responsibility cannot be avoided. If no sanctuary remains untouched, then stewardship must be universal. Protection cannot be reserved for forests and rivers alone. It must extend to the abyss, to the silence, to the places unseen but not unimportant. The trench is not beyond reach. It is within the circle of care, if only humanity chooses to see it that way. In the end, the hidden dangers of the trench are not only pollutants and plastics. The true danger is indifference. To ignore the evidence is to allow the silence to be filled with fragments of neglect. To acknowledge it is to accept a responsibility that extends as deep as the ocean itself. The abyss waits not as a sanctuary, but as a testament. It carries the echoes of civilization's noise, but it also carries the possibility of change. The Mariana Trench is no longer just a place of mystery. It is a record of resilience, of adaptation, and of intrusion. In its amphipods and sediments lie the truth of what it means to live in an interconnected world. Humanity cannot separate itself from the deep. It is already there, woven into the biology of creatures that should have remained untouched. The question, then, is not whether the abyss will endure. Life in its own way always endures. The question is whether humanity can learn to see itself in that endurance. Whether it can look into the silence and hear its own echoes, and in doing so, choose to change the sound it leaves behind. The Mariana Trench is not only a place of depth, it is a place of time. To peer into its black waters is to look backward into the earliest chapters of Earth's story. The abyss is more than a physical boundary. It is a capsule, a hidden archive where the chemistry of life's origins may still echo in silence. In its sediments and in its creatures, fragments of the past endure, preserved not in stone but in pressure, in darkness, in the rhythms of a world unbroken by light. Scientists who study the trench describe it as a window into Earth's early oceans. Billions of years ago, before forests grew and before continents formed, Earth was a water world. Its seas were saturated with minerals, stirred by volcanic heat, and charged with chemical gradients. These primordial conditions gave rise to life, though how remains one of the great unsolved mysteries. The trench, with its hydrothermal vents and serpentinization processes, mirrors those ancient environments. It is a living experiment, a place where water, rock, and chemistry collide in ways that resemble the alchemy of life's beginning. DNA analysis of deep-sea organisms strengthens this link. In amphipods, microbes, and other trench dwellers, researchers find evidence of evolutionary pathways stretching back hundreds of millions of years. Some lineages are so ancient they seem unchanged, fossils still alive, carrying within their genetic code echoes of the first adaptations to pressure and darkness. The xenophyophories, single-celled giants sprawling across the seafloor, are examples of such endurance. Their simple, sprawling forms reflect evolutionary strategies that may have been present in the earliest eukaryotes, preserved in isolation beneath the crushing weight of the sea. This raises a profound question. Is life in the trench not merely adapted to extremity, but descended from extremity? Could it be that the abyss shelters descendants of the very first cells that crawled from chemistry into biology? If so, then to study trench life is not only to study survival, it is to study origins. Each amphipod, each bacterium, may carry whispers of the first spark of life on Earth. In their proteins and enzymes lie answers to questions humanity has asked for centuries. How did life begin? And under what conditions does it persist? Philosophically, the trench becomes a metaphor for time itself. In Einstein's theory of relativity, time is not constant. It bends with gravity, it stretches with motion. Near massive objects, clocks slow, their ticks stretched into longer beats. The abyss mirrors this phenomenon. In its crushing silence, the trench feels like a slowed heartbeat of Earth, a place where time itself is suspended. Species evolve slowly here, sheltered from the turbulence of the surface. Sediments accumulate grain by grain, undisturbed for millennia. To descend into the trench is to enter a place where the planet's pulse beats differently, more slowly, as though Earth itself lingers in reflection. Stephen Hawking once described extreme environments as natural laboratories. To him, they were testing grounds for theories not only of physics but of life. The abyss in this sense is such a ground. It challenges assumptions, stretches definitions, and forces new perspectives. If life thrives here, then it must thrive elsewhere. If evolution writes its script in darkness and pressure, then the cosmos may be filled with verses written in oceans beneath ice, or in atmospheres choked by chemistry we cannot breathe. The trench does not exist in isolation. It becomes a bridge, linking Earth's depths with cosmic possibility. The sediments at the bottom of the trench add another layer to this reflection. Core samples reveal not only minerals, but the remains of life that has fallen from above for millions of years. Tiny shells, organic fragments, chemical residues, they form a layered record, an unbroken chronology of oceans long gone. These sediments hold secrets of climate, of evolution, of extinction. They are time itself, compacted into silence, waiting for science to read them. In their layers, one can trace the breath of Earth across epochs, as though the trench were a diary written not in words but in dust. Even the chemistry of trench life speaks of endurance across time. Extremophiles that thrive under pressure do so with proteins stabilized by unique molecules, osmolytes that prevent collapse. These adaptations echo ancient strategies. perhaps the same strategies that allowed early microbes to endure in volatile, unstable seas. Studying them is not just biology. It is archaeology of the molecular kind, uncovering patterns that may have remained unchanged for billions of years. Yet the trench also offers reflection on humanity's relationship with time. Above, on the surface, life is restless. Civilizations rise and fall in centuries. Technology changes in decades. Human lives flicker in the span of years. But in the trench, change is glacial. Organisms live in constancy, untouched by sunlight, ruled by chemistry older than the continents. To encounter them is to be reminded of humility. The trench does not measure time in days or years. It measures in eons. It reminds that life is not bound to human scales, that endurance is its own form of triumph. This contrast deepens the philosophical tension. If the trench holds relics of the past, does it also hold lessons for the future? If life can persist unchanged for hundreds of millions of years in silence, what does that say about humanity's fleeting presence? The abyss becomes both mirror and challenge. It shows that life does not require civilization, progress, or light. It requires only persistence, chemistry, and adaptation. Humanity is not the pinnacle of this story. It is a moment, brief and bright, against a backdrop of endurance that stretches into the dark. In this way, the trench redefines the concept of survival. It is not dramatic or triumphant. It is quiet. It is patient. It is the snailfish drifting in silence, the amphipod scuttling through sediment, the xenophyophore spreading slowly across the floor. These are not stories of conquest. They are stories of continuity. They remind us that time does not belong to speed or brilliance alone. It belongs also to those who endure, who adapt, who persist across ages. The abyss, then, is a paradox. It is at once ancient and current, timeless and yet a record of time itself. To study it is to step into Earth's earliest moments, but also to glimpse possibilities for the cosmos. If extremophiles in the trench echo the first cells of Earth, then perhaps extremophiles in alien oceans will echo the trench. If the abyss is a time capsule, then the universe may be filled with similar capsules, each holding its own story of beginnings. Hawking's perspective lingers here. To seek life elsewhere, one must look to the extremes. Not to the comfortable, but to the impossible. Not to the familiar, but to the alien. The trench embodies this principle. It shows that life is most revealing when it is stretched, when it is tested, when it is forced to persist against odds. It shows that to understand the cosmos, one must first understand the silence beneath Earth's seas. And so, the Mariana Trench is more than depth. It is duration. It is memory. It is an echo of the first heartbeat of life, slowed and preserved in water and stone. To descend into it is to step not only into space but into time, to witness the persistence of existence across billions of years. It is to see that life once born does not vanish. It transforms, it adapts, it endures. The abyss reveals this truth with quiet eloquence. It whispers that time is not only linear but layered, that the present carries within it the bones of the past. It shows that the silence of the deep is not emptiness but fullness, fullness of memory, of continuity, of resilience. The trench is Earth's slowed heartbeat, and within its rhythm lies a lesson for humanity, that life is vast, patient, and eternal in ways that stretch beyond imagination. The abyss waits in silence. Its waters are black, its pressure relentless, its horizons infinite. To gaze upon it is to feel the weight of strangeness, an alienness born not from distant galaxies but from the very bones of Earth. The trench is both familiar and foreign, part of the same planet that gives rise to forests, rivers, and skies, yet so removed from those worlds that it feels like another realm altogether. It is Earth, and it is not Earth. It is a reminder that the planet we inhabit is still a mystery, still larger than our imagination, still capable of humbling us with its hidden depths. When explorers descended into its silence, they expected desolation. They expected lifelessness, a void pressed flat by crushing weight. Instead, they found resilience. Amphipods carrying on the ancient dance of survival, snailfish drifting in translucent fragility, enduring where no vertebrate should endure. Xenophyophores sprawling across the seafloor like fragile monuments, building worlds within themselves. Life persisted, not in spite of the abyss, but because of it. The trench did not extinguish existence. It sculpted it into new forms, reshaping biology into something both improbable and inevitable. And so, the trench became more than a place. It became a reflection. Humanity has long looked upward to the stars, searching for meaning in the infinite. Yet the descent into the trench reveals that the alien lies not only above, but below. That the frontier is not only in space, but in silence. The abyss mirrors the cosmos, an ocean of blackness scattered with points of light, where survival itself becomes the message. To explore the trench is to explore the same mystery that drives telescopes toward galaxies, the question of where life endures and why. This reflection cuts deeper than science. In the amphipod's fragile shell and in the xenophyophores' sprawling form lies a lesson older than civilization. Life bends but does not break. It adapts to crushing weight, to eternal night, to scarcity beyond imagination. It rewrites itself to survive. Humanity, restless and fragile, is reminded that survival is not always about dominance or control. Sometimes it is about acceptance. Sometimes it is about reshaping, about persistence in silence. The abyss speaks of endurance, but it also speaks of consequence. Within amphipods, scientists found not only resilience, but microplastics. In sediments, they uncovered the traces of industrial toxins and radioactive isotopes. Even here, in the most remote place on Earth, the echoes of civilization arrive. The silence of the trench carries the noise of human life, the fragments of its industry, the shadows of its reach. The abyss is no longer untouched. It reflects not only resilience but responsibility. It whispers that there are no sanctuaries left, no places beyond consequence. To care for Earth is not optional. It is imperative if life's persistence is to remain more than a fragile balance. Philosophically, the trench collapses distance. It shows that the mysteries of the cosmos are not far. They are beneath our feet. In reaching for the stars, humanity rediscovered that the greatest unknowns may lie at home. The abyss is a mirror of the universe. Its creatures echo the possibilities of Europa and Enceladus. Its chemistry echoes the first stirrings of life. Its geology echoes alien worlds. To explore it is to practice for the cosmos, to rehearse for the moment humanity peers into the oceans of another world and asks the same question: is there life here? Time itself lingers in the trench like a slowed heartbeat. Sediments layer undisturbed for millennia, keeping records of climates, extinctions, and evolutions. DNA whispers of ancient lineages unchanged across ages. The abyss becomes a capsule, a slowed pulse of Earth's memory, reminding that existence is not fleeting but layered, continuous, patient. To descend into it is to step into time itself, to feel the immensity of life's endurance stretching backward for billions of years and forward into futures unknown. In this stillness, the emotional weight grows. Humanity sees itself reflected in the trench, not as conqueror but as participant, not as master but as echo. The amphipod carrying microplastics becomes a parable of consequence. The snailfish enduring pressure becomes a parable of resilience. The xenophyophore sprawling in silence becomes a parable of persistence. Each creature is a mirror, reflecting what it means to exist in a universe of extremes. The crescendo of this story is not discovery alone. It is revelation. What humanity found in the deepest place on Earth was not just life, but a mirror of the cosmos, of ourselves, of the fragile persistence of existence. The trench reminds that the boundaries of life are wider than we imagine. It shows that resilience is not extraordinary. It is fundamental. It whispers that survival is not conquest but adaptation, not force but patience. As the lights of submersibles fade upward, as the abyss returns to its silence, the lesson remains. The deep does not need humanity to exist. It does not call out for discovery. It simply endures. Its creatures move in blackness, its sediments gather, its geology reshapes. It waits, timeless, patient, carrying within it the memory of Earth and the echo of possibilities yet to come. Humanity leaves, but the abyss remains, unchanged, eternal in its endurance. And so, the final image is not of desolation, but of persistence. The abyss whispers not of emptiness, but of endurance, and of the unanswered question of what other depths, cosmic or earthly, are yet to be found.